What is up, Math 7? It is numbers 21 through 25 of your SBAC review here. We're almost through the entire practice test. Please keep notes and make sure you're getting your credit for this in-class assignment. And make sure that you're writing things down in your own words and that you make note of things that you're definitely going to remember for that test on Tuesday. So let's take a look at our questions. Question number 21 says the circumference of a circle is approximately 37.7 centimeters. Enter the radius of the circle in centimeters and round your answer to the nearest whole number. So here's where we need to understand one main fact about circles, and that is this word circumference. Now, if you don't remember what the circumference formula of a circle is, the circumference is equal to 2 pi times the radius. Now, the information that's given to us in this problem is that the circumference itself is 37.7 centimeters, and what we're trying to find is the radius. So let's substitute what we know into this equation. I know that my circumference, that capital C there, is 37.7, and what it's equal to is 2 pi r. Now, if r is what I'm trying to get all by itself, what I'm trying to solve for, in order to get that by itself, all I'm going to do is divide by 2 pi. Now here is where your calculator comes in handy. The 2 pi's cancel on this side, and I'm left with the radius, what I need to find, and all I need to plug into my calculator is 37.7 divided by 2 pi. Now if you're wondering how to convert 2 pi, all you need to do is multiply 2 times pi first, or 2 times 3.14 first, and divide 37.7 here. This is a perfect opportunity for you to use a calculator. So make sure that you use that button. There should be a button up above that has a little calculator symbol on it. Use it to your advantage, especially in problems like this where it just takes one step to solve. Problem number 22 requires us to remember the inequalities here. Now what it gives us is it gives us an expression for the inequalities, which is 6x minus 4 is less than 8. Now, one of the things that I can do via process of elimination is already know which one of these arrows that I can drag that make any sense. Now, since it's just a less than symbol, I know that this arrow has to be pointing to the left, and it has to be an open dot. So the only one that fits that criteria, the only one that I'm dragging here, is going to be this guy. Now, all I need to figure out is where I'm going to drag this guy on the number line. So in order to figure out that number, I'm going to solve this just like I solve a regular equation. So I'm going to add 4 to both sides. 4's cancel. I get 6x is less than 8 plus 4 gives me 12. Oops, 6x. And my last step here is to divide both sides by 6. Overlap in here a little bit. And I get x is less than 12 divided by 6 gives me 2. So there's my answer. And now all I have to do is drag my arrow all the way over 2, which would give me my final graph answer. So there is the work for number 22. Number 23 here is a critical thinking problem. Maria claims that any fraction located between 1/5 and 1/7 on a number line must have a denominator of 6. It says to enter a fraction that shows Maria's claim is incorrect. So here's what we should do. Let's draw the number line. I know that 1/5 and 1/7 are definitely between 0 and 1. So they're parts of 1. So say this is 1/5 and 1/7 is definitely smaller than 1/5. So if I were to try and find a fraction that has a denominator of 6, I need to figure out if I can find a fraction that's not in between both of these different fractions, the 1/5 and the 1/7. So let's think creatively here. What if I chose something like 5/6? What I know for sure is that 5/6 is definitely outside of those two fractions, and this is the type of fraction that I can say definitely proves Maria's claim incorrect. I can get even more creative than that. What if I put the fraction 6 over 6? That equals 1. I know that 1 is definitely outside of these two fractions. So I can get creative, and there are multiple answers here, and I'm going to repeat that, multiple answers here that could prove your point. So definitely make sure you get creative in these types of critical thinking problems. Number 24 here is a volume problem. This says a company makes two sizes of boxes shaped like rectangular prisms. The large box is 16 inches tall by 10 inches wide and then 10 inches long. The drawing shows the dimensions of a small box, and that's pictured below. So we've got a two-part question here. Part A says, what is the maximum number of small boxes that can fit inside the large box? So here's our work. What we need for sure is our volume equation, which is just length times width times height. Now we need to figure out what the volume of the small box and the large box is to figure out how many of the little guys fit into the big guys. So let's start with the large box. The large box's volume is found just by multiplying the three numbers that they give us in the top section here. So I see that the large box is 16 inches by 10 inches by 10 inches. Now once I multiply this out, I got to make sure that I keep this separate from the small box volume. So when I multiply this out, I get 16,000 as my volume for the large box. Now I'm going to place a placeholder on that volume here because now I need to find the volume of the small box. Now the small box has these three dimensions as labeled in the picture. So the small box's volume is 4 times 2 times 2. Multiplying those three numbers out gives me 16. So all I'm going to do now in order to answer part A is I'm going to do one very simple division problem. I need to figure out how many of these small boxes volumes fit into the large volume here. So I'm going to do 1600 divided by 16. Now once I do that, what I should find is that there is exactly 100 boxes that can fit into this specific scenario. Now part B says the company plans to increase the width and length of the large box by 4 inches to each new larger box. Then it asks us to do the exact same thing. So although I'm not going to finish part B for you, setting it up is very straightforward. Instead of the large box having the dimensions of 16 times 10 times 10 as it was at the very beginning, all I'm going to do is add 4 inches to each of the dimensions just like it says in part B. So 16 plus those 4 extra inches gives me 20 times 14 times 14 because I'm adding those 4 extra inches to every single dimension. Now once I multiply here, I'm going to get a brand new number. This brand new number, I'm going to follow the exact same method as I did in the first portion. So I'm going to find that number and then divide it by the small volume 16 to find out how many boxes are in here. Now this is another definite calculator problem. So take advantage of calculator problem. Take advantage of that calculator button when you see it, and definitely make sure you think your way through volume problems, especially if you know your volume equation. So volume is length times width times height for any box that you might see. Number 25 here brings us into another scenario in which you have to be massively careful when you read your way through the problem. So it says Lenny bought a motorcycle for 12.5% in tax. The tax added $1,437.50 to the price of the motorcycle. What it's asking us to find was the original price of the motorcycle. Now, originally, what you'd probably think you would do is multiply 12.5% times $1,437.50, but you would be misunderstanding what the question's asking you. In reality, the scenario is this. Whatever the motorcycle was worth, which I'm saying is X here, so the original price of the motorcycle X times 12.5% would give you $1,437.50. So it's a much different problem than just multiplying the two numbers together, because if I want to solve for X, what I really need to do is divide both sides by 12.5% to find my original sales price. Now just remember that when you divide by a percent, you got to switch it into its decimal form, and in this case it would be 1437.50, the sales tax that they give us at the beginning, divided by 0.125. Now again, this is a definite calculator problem, because after this you would get your original price of the bike, which is exactly what you're trying to find. So take out that calculator, use that calculator button, and make sure you divide here accurately. So be very, very careful in understanding what they're asking you specifically in each of these questions. To the end of this specific review, please stay tuned and subscribe for more. You will be getting more and more prep as we move forward. Just make sure you gain that confidence and just keep on going. So Emily, can you tell them, keep going and do your work? Say, keep going and do your work. Look at Emily. Emily, say, keep going and do your work.
Going.
And do your work.
And do work.
Yeah. Say bye.